Hi everyone, I'm Paul, an engineer here at NI, and welcome to our YouTube channel where you can learn tips and tricks to help you design, validate, and test products quicker and more effectively. So in this series, we'll go through multiple test and measurement topics, from using different languages like LabVIEW, Python, and C# to operate test instruments, to automating manual processes and enabling data analytics. So today, I have a special guest, Daniel, who is an EE here at NI and who has Python code that will be used in the MeasurementLink Developer. So what is MeasurementLink Developer? MeasurementLink Developer is a new solution from NI that helps with going from interactive to automated process for validation quickly. And then some of the features of MeasurementLink Developer offers like third-party instrument support, Python GUI interface, you can mix and match programming languages, and much more. So welcome, Daniel.
Thanks for having me, Paul.
So what type of hardware are we using today? Just a quick overview.
Today, we'll be integrating a third-party power supply, the RMX4104, and our DUT will be a Raspberry Pi 3.
Awesome. And then we're integrating today Python code?
Yeah.
All right, how about you walk us through?
Let's take a look. So here, I wrote a simple driver for the RMX4104. I started with the driver that I downloaded from the NI website.
Okay.
It is a C-based driver, so to move this over to Python, I had to use C types and wrap some of the functionality. So here I created two simple methods, one to turn on the power supply, set the power supply voltage and the current limit, and another one to read back some information, the output voltage and the output current.
Yeah, okay.
Here is my top-level Python code. This is heavily based on the MeasurementLink template that NI provided, and so I'm going to run through some of the code here. So here at the beginning, I provide some information. This is pretty much from the template, measurement information and service information. And this is where I provide some naming stuff, a revision number, as well as a link to a GUI that I'll talk about in a little bit. The next part of the code is where I define the inputs and outputs from the Python code to the GUI itself. So where you see configuration, it's an input, and where you see output, it's an output. So for some of the inputs, I have supply voltage, supply current, acquisition time, stress tests. We define some tests, and I'll go over that in a little bit. On the output side, we're looking at the output voltage, current, calculated power, and some information from the Raspberry Pi, CPU usage, CPU temperature, and some revision information about the Raspberry Pi itself. In the meat of the code, this is where I use the ZMQ library, which utilizes data sockets to send information between the host and the DUT.
Okay.
On the DUT side, we're also running a little bit of Python code. All it's doing is receiving some messages and returning the information that I request. So the CPU temperature, revision information.
Sense, yeah.
Yep. At the end, there is some simple data processing, and kind of in the main, all we're doing is running some of the power supply drivers that I talked about previously. And that's my Python code.
Awesome. All right. Let's integrate with MeasurementLink Developer. You're going to like this. It's pretty cool and easy to integrate. So the first step in integration would be to define your visual interface. So let's open the visual interface editor, one of the features of MeasurementLink Developers. And inside here, you'll start a new project, and then you'll do file and start a new file for the editor. And in the editor, you'll see these options where you can drag and drop your strings, graphs, and things like that to create a visual interface for your Python code. So how about you drag and drop 3, and then once you do that, select your code. So you'll select as you select your Python code, when you drag it, as you can see, all these variables show up, and you can easily select what's in your Python code. So it's a great way to build a visual interface quickly, right?
Absolutely. And there's nice little features like auto-aligning, selecting the parameters that you've selected, so it's awesome.
Awesome. All right, so the next step, for our purpose, we already created a visual interface. So the next step would be to launch Instrument Studio. So if anyone is watching, in case you're wondering what Instrument Studio is, there's a video that we recorded previously, so we'll have a link below to go to it. But for us, so we'll open the visual interface that we created. So Daniel, why don't you walk me through what you have here for your visual interface?
Sure. On the left, you'll see some power supply settings. So this is where you can set up your power supply voltage and current limit. We have some basic configuration for the test settings. So in this case, we'll be running stress test 2.
Okay.
Stress test 2 is where we apply CPU load to the Raspberry Pi 3, and then we'll look at some of the information that comes back.
Oh, nice.
And on the right is where we have our outputs. So we look at the supply voltage, supply current, and calculated power, as well as CPU usage of the Raspberry Pi, temperature, and some revision information.
Awesome. All right, so I'm excited. Let's run this and let's see this data.
So going over the data, on the right, we're looking at the outputs. So we see something pretty close to 5 volts, which is what we're expecting since we're requesting 5 volts. Our current draw is about 0.4 amps, and so we have our calculated power of a little over 2 watts. On the Raspberry Pi side, we see an elevated CPU usage at 48%, slightly elevated temperature, and revision information as expected.
Cool. Yeah, so what do you think of the process so far integrating your Python code with this MeasurementLink Developer?
So far, I think it's been really easy to make a GUI and just run a basic benchtop measurement.
Yeah, okay. And then while you were working on this, do you have any questions so far that you think would like to be answered?
Yeah. So is there a way for me to run multiple source codes in Python?
Oh yeah, that's a great question. So yeah, so you can run different languages, right, and then different source codes that you can edit in your manual layout, so you can choose whatever you want, or you can have multiple running in parallel all together. So yes, great question. What other questions do you have?
Yeah, so you kind of hinted on this before, but does MeasurementLink support any other languages?
Oh, great question. Yeah, it does support LabVIEW, Python, and then C#, so you can mix and match these languages, which is, makes it unique. What other questions do you have?
So the last thing, I'm really happy about the benchtop measurement, but I want to move to automation. Can you help me with that?
Oh yeah, that's $1 million question, Daniel. So yeah, to go to automation takes less than a minute, and it's done through Testan. So let's launch Testan, which is a sequence software that NI provides. So in here, once you install MeasurementLink Developer, you get a new step type, which is called measurement. So all you have to do is drag and drop into your sequence. And then in the sequence, you're able to select your Python code for this instance that we're doing. And then all your variables show up right here. And now another great feature of this is that you can just select which variables you want to log very quickly and see the data, right? And start automation like that. So select what you like, and then we can test it out, see how it matches the results from the visual interface.
Sure.
All right. So we'll do the step process now. It'll go step by step into it, and then it should give us results and log what you selected so far.
So let's take a look at the data. This looks pretty similar to what we looked at before. So our inputs, 5 volts, 1 amp current limit, and we're running stress test 2. On the output side, the voltage is 4.99, which is pretty close to what we asked for. The current draw is about 0.46 amps, elevated CPU usage, elevated temperature. Everything looks great here.
Nice, so it passed all the stress tests, right?
Exactly.
So is Raspberry Pi ready to join the knighthood of the Duds?
Yes.
All right.
Whatever that means.
I'm excited. All right, so yeah, thanks for showing and walking me through your Python code. Thanks for helping me integrate and showcase MeasurementLink Developer.
Thanks for having me.
Thanks for being, So we hope you enjoyed today's video, so please don't forget to drop a like and hit subscribe to keep learning more tips and tricks, and see you next time.